Hello, my dear students. Welcome to Quarter 2, Module 3. Once again, I am Teacher Jenny. And on this video, we will be dealing with evaluating algebraic expressions. So at the end of the lesson, you are expected to evaluate algebraic expressions for given values of the variables. But before that, let us recall on the PEMDAS rule. PEMDAS stands for P parenthesis E exponent, M multiplication, D division, A addition, and S subtraction. So we have to simplify first terms or numbers inside the parentheses, and after which we have to simplify numbers or terms with exponents. Then after that, proceed to the multiplication and division symbols. Take note, multiplication and division comes together. So you must start from the first operation from left to right with the operations multiplication and division. Then after that, proceed to addition and subtraction. So again, like multiplication and division, for addition and subtraction, we have to work on operations from left to right or numbers from left to right. We have here the application of PEMDAS. Sample. 36 divided by 5 minus 1 plus 2 cubed times 6 minus 20. First, we have to work on the operations inside the grouping symbol or inside that parentheses. So that's 5 minus 1. So we have 4. So it's now 36 divided by 4 plus 2 cubed plus or times 6 minus 20. And then after the parentheses, since we have here an exponent, that should be simplified next. So 2 cubed, that is equal to 2 times 2 times 2. 2 times 2 is 4, times 2 is 8. So we now have 36 divided by 4 plus 8 times 6 minus 20. And then, since we already simplified the parentheses and the exponent, we are now ready to work on operations, division, and multiplication. So from left, we have 36 divided by 4 first, and that's 9. Then bring down 8 times 6 minus 20. And then next, we have the multiplication. 8 times 6 is 48. Then 9 plus 48 is 57. Bring down minus 20. And 57 minus 20, that is 37. So the answer for number 1 is 37. Another example. Again, we have to work on the parentheses first. That's 10 minus 6, so we have 4. And then, we have here an exponent, that's 3 squared. 3 squared is the same as multiplying 3 to 3. So 3 times 3 is 9. So that's 2 times 9 plus 4 divided by 4. Now from left, we have the multiplication. 2 times 9, that's 18. Plus 4 divided by 4. Take note, we have a division symbol, so that should be simplified next. 4 divided by 4 is 1. And 18 plus 1 is 19. Take note, in solving mathematical expressions, we should follow a certain rule, such as the order of operations, so that everyone will arrive at the correct answer. Always remember the PEMDAS rule. We have here a problem. Find the area of a rectangle whose length is 5 centimeters and width is 3 centimeters. If you can still remember the area of a rectangle, it's A equals length times width. And since our length is 5 centimeters and our width is 3 centimeters, we now have 5 centimeters times 3 centimeters. And that is 5 times 3 is 15 square centimeters or centimeter square. Take note, this is an elementary lesson. And our lesson for today is just like this. So I hope we will take on our discussion easily because it's or you already have knowledge on our next lesson because the process of substituting value to a given variable is evaluating the given algebraic expression. So, in solving the area of the given rectangle, we already evaluated an algebraic expression. So, the algebraic expression here is the formula for the area of a rectangle. Then we substituted the length and width to find the area. In evaluating algebraic expression, you have to follow these two steps. First, substitute or plug in or replace the given values of the variables in the algebraic expression. So that's the first. Second, perform all mathematical operations following the order of operations or the PEMDAS rule. So we only have two steps. First is substitute, second is, of course, solve. Examples. First, evaluate 40 divided by x minus 2 times x plus 4 when x equals 5. So, from the given algebraic expression, 40 divided by x minus 2 times x plus 4, we have to change all x's to the given value of x, which is 5. So it is now 40 divided by x is changed to 5 minus 2. Then we have inside the parentheses, instead of x, we now have 5 plus 4. We are already done substituting, so we are now ready to solve. Starting from the parentheses, we have 5 plus 4, that's 9. Then from left to right, 40 divided by 5 is 8 minus 2 times 9 is 18. So 8 minus 18 is negative 10. Always remember the rule for addition and subtraction. It's SADS. Same signs, we're going to add. Different signs, we're going to subtract. And if you add, you copy the common sign. If you subtract, you copy the sign of the larger number. But first, you have to always remember that we consider the sign or the operation a sign, not an operation. Like this one, instead of 8 minus 18, we have two numbers, 8 and negative 18. they have different signs, so we're going to subtract their absolute value or do not consider the sign. So we have 18 minus 8, that's 10. And since 18 is larger than 8, we have to copy the sign of 18. So that's negative 10. Another example. Evaluate x plus 5 if x equals 2. So from x plus 5, we will change x to 2. So that's 2 plus 5. So it's 7. Another example. Find the value of 2y minus 3 if y has the values 0 and negative 4. Let's work on 0 first. So from 2y minus 3, take note, we have here 2y. It's a term with a number and a variable. Always remember, a number beside a variable or two variables written side by side represent multiplication. So if we have a number and a variable together, that's like 2y, or variables written side by side like AB or CD. Take note, they represent multiplication. So for 2y minus 3, if we change it or if we substitute 0 to y, we do not have 20 minus 3 because the operation between 2 and y is multiplication. So we have 2 times 0 minus 3. And 2 times 0 is 0 minus 3 is negative 3. For b, y equals negative 4, we have 2 times negative 4 minus 3. 2 times negative 4, different signs yan, and multiplication. So we have negative 8 minus 3. It's negative 11. Another example. If a equals 3, what is the value of 3a plus 5a? So again, we have to substitute. From 3a plus 5a, we have 3 times 3 plus 5 times a, which is 3. Simplifying, we have 3 times 3, that's 9. 5 times 3 is 15. So 9 plus 15 is 24. Another example. Evaluate p minus 6q if p equals 4 and q equals negative 3. So from p minus 6q, take note, we have two variables and we have a value for each variable. So we have p, that's 4, minus 6 times the value of q, which is negative 3. Simplifying, 4 minus 6 times negative 3, we have to start first from the product of 6 minus 3, and that's negative 18. 4 minus negative 18 is the same as 4 plus 18. So we have 22. Take note, minus negative is the same as plus. Another example. What is the value of x squared minus 2x plus 4 when x equals 3? So by substitution, we now have 3 squared minus 2 times 3 plus 4. Again, take note, all the variables x were changed into 3. To simplify, we have to start first with 3 squared because it has an exponent. So that's 9 minus 2 times 3 is 6 plus 4. 9 minus 6 is 3 plus 4 is 7. Another example. Evaluate the square of a plus b minus 5 if a equals negative 2 and b equals 7. So again, we have two variables, a and b. A equals negative 2 and b equals 7. So by substitution, we have a plus b, that's negative 2 plus 7 squared minus 5. Break on the parentheses first. So we have negative 2 plus 7, different signs. So we're going to subtract. 7 minus 2 is 5. Larger number is 7. Therefore, we have positive 5 squared minus 5. 5 squared, that's 25 minus 5. So we have 20. Next example. Evaluate b times b minus 10b divided by 2 plus 5 squared if b equals 5. So by substitution, we have 5 times 5 minus 10 plus, times 5 divided by 2 plus 5 squared. So we have 5 times 5 minus 10 times 5 divided by 2 plus the simplified form of, or simplified 5 squared, that's 25. And then we have to multiply 10 times 5, that's 50. Divided by 2 is 25. And then working on 5 minus 25 plus 25, that's 5 minus 25 first is negative 20 plus 25, so we have positive 5. Then times 5 is 25. For addition and subtraction, you can also do combining or adding first terms with the same signs. Like this, 5 plus 25 is 30, then minus 25 is 5. Another example. We have three terms here or three variables here, a, b, and c. A equals 1, b equals negative 2, and c equals 4. We have to evaluate 8ab minus 3a all over 15 plus c. So by substitution, we have 8 times 1 times negative 2, which is the value of b, minus 3 times the value of a, which is 1, all over 15 plus the value of c, which is 4. Simplifying, we have 8 times 1 is 8 times negative 2 is negative 16. Then, negative 3 times 1 is negative 3 over 15 plus 4. Combining the numerators or subtracting the numerators, we have negative 16 minus 3, that's negative 19. Over 15 plus 4 is 19. And negative 90 divided by 19 is negative 1. Another example. What is the value of 5 minus 2x plus x squared if x equals 1 half? So we have a fraction. So by substitution, we have 5 minus 2 times x is 1 half plus another 1 half for x squared. We have 1 half squared. Simplify first. 1 half squared because it has an exponent. We have 5 minus 2 times 1 half plus 1 half squared is the same as 1 half times 1 half. So that's 1 times 1, 1. 2 times 2 is 4. So we have 1/4. Next, work on the multiplication. 2 times 1 half. So we have 2 times 1 is 2 over 2. 2 divided by 2 is 1. So that's 5 minus 1 plus 1/4 now. Next, 5 minus 1 is 4 plus 1/4. It's 4 and 1/4 or 17 over 4, or in decimal form, it's 4.25. Now, how are we going to apply evaluating algebraic expressions in real-life situations? First example, Alpheus wants to mark a rectangular court on the gym floor using a masking tape where he can practice badminton with his friends. He wants it to have a length of 25 feet and a width of 16 feet. How long should the tape be to mark his rectangular court? So what is asked is the measurement of the tape to be used to mark the rectangular court. And take note, we are dealing or talking with the perimeter of the rectangular court. And for the perimeter of a rectangular court, since it's in a rectangle shape, then it's P equals 2L plus 2 width, where L is for length and W is for the width. So working on 2L plus 2 width, we now have 2 times the value of the length or the length of the rectangular chord is 25 plus 2 times the length of the or the width of the chord it's 16. 2 times 25 is 50 plus 2 times 16 is 32. And 50 plus 32 is 82. Therefore, the tape should be 82 feet long to mark the rectangular chord. Another example, the cost of 4 bags of popcorn Hadassah, both in SM, is 3x plus 5 pesos. What is the cost of each bag of popcorn if x equals 25? So for our solution, take note that 4 bags of popcorn is equal to 3x plus 5. Since x equals 25, then we have to substitute x by 25. That's 3 times 25 plus 5. So we have 75 plus 5 is 80. That means 4 bags of popcorn costs 80 pesos. Now, to know the cost of each bag of popcorn, we divide 80 pesos by 4 because that 80 pesos is good for the 4 bags. So that's 80 divided by 4, it's 20 pesos. Therefore, each bag of popcorn costs 20 pesos. Okay, before we end, always remember that evaluate means we have to determine the value of something. So when we evaluate an algebraic expression, we have to find the value of that algebraic expression by substituting the value of the variable to the given algebraic expression. So, to evaluate algebraic expressions, we have to follow 2 steps. First is to substitute and second is to solve. That's all and thank you for watching.